The functions f and g are given. Here's f of x, here's g of x. G is the result of multiplying both the numerator and denominator of f by the reciprocal function, which is 1 over x. 3 of the below statements are true and 1 is false. Identify the false statement. Choice A, f of x is equal to g of x for all x in the domain of f. Choice B, both f and g share a vertical asymptote x equals 3. Part C, or choice C, both f and g share the horizontal asymptote y equals 3/2. Choice D, f and g share an x-intercept of -3, 0. Let's actually look at the graphs of both of these functions. So I'm going to switch to a graphing calculator tool, and here's our first function, 3x plus 9 all over 2x minus 6. Here's what we have. And then our other function for g of x is given in red. So far, just by looking at them, it does appear that they are both equal for all values of x. But let's double check that. Okay, we have an x-intercept of 3, 0 in this case. Notice when I did click on the function, there was no y-intercept that popped up, which usually happens in Desmos. And if I go to where the value is 0, notice there's a hole there and it's undefined. So there's no y-intercept for g of x. So f and g share an x-intercept of -3, 0. That is definitely a true statement. Both f and g share a horizontal asymptote of x equals 3/2. Well, if we use the rule of rational functions, looking at the degree here, this is the same degree, so if we divide these leading coefficients, we get 3/2. Okay, that works. And here, we would also end up getting 3/2, so this will be true. Both f and g share a vertical asymptote at x equals 3. If we substitute 3 in for x here, we'll get 6 minus 6, which is 0, and we'll get 9 plus 9, which is 18. So we get a constant value over 0. That does tell us it's going to be an asymptote. If I put 3 in for x here, I'll get 3 plus 9 over 3, which is 3. So 3 plus 3 is 6. And then if we have 2 minus 6 over 3, 6 over 3 is 2. We'll have 2 minus 2, that's 0. So we are going to have a vertical asymptote in both of these. Now, the two functions being equal to one another in all x within the domain of f, that one came out to be not true. If we show just f, we do have both an x and a y-intercept. But if we bring g up, we do not have the same y-intercept. It's undefined there. There's a hole. We do have the same x-intercept though. So therefore, choice A is our false statement.